This is Gats. Now, Jonas from Djupviks calls this one an angry filter. And that's honestly the simplest description I can give you. But it's a little bit more than that. Gats is a grainy reverb feeding into a wasp-style bandpass filter with sample and hold modulation built into the signal path. It's not trying to be clean or precise. It's an effect module with a lot of character. The sample and hold can run off its own internal clock or sync to external tempo. And by default, it's sampling the incoming audio itself, so you get this stepped glitchy texture on top of the filter movement. But the real trick is on how the offset control lets you shape that response from aggressive ducking through to keeping the filter permanently cracked open. Let's walk through it. Audio comes in here with a gain control to push or pad your signal. Everything passes through the reverb stage first. And this isn't a lush, clean reverb, it's grainy, lo-fi. Adds texture before you even hit the filter. You've got this feedback control and a switch for pre and post filter on the feedback. The filter is a wasp-style bandpass. If you've used wasp filters before, you know they have a particular nastiness to them, especially they don't behave politely when you push the resonance. So that's the basic operation. A reverb with a feedback path that can go pre or post filter, and this wasp-style bandpass filter. Pretty fun before you even get to the modulation. Now let's talk about the modulation. This is the CV knob. When I push it up, you start to hear the sample and hold circuit affect the filter. Just turn the feedback down so you can really hear that. Now what we've got here is we're using the internal clock and it's sampling at the rate that the clock decides it's sampling the incoming input. You get all of this glitchy niceness, especially with the resonance turned up. The CV controls the amount that the sample and hold affects the frequency. The clock goes into fun times, nearly audio rate, and can also go really slowly. Now you've got the offset knob. This decides how the sample and hold modulation affects the filter. Center position is neutral. Sample voltage behaves as you'd expect. Turn it fully counterclockwise and you're adding negative offset. So high voltages actually close the filter down. It's a ducking effect. Your loud transients get quieter. Fully clockwise, you're biasing everything positive, so the filter never closes below a certain point. Now what you can do as well is you can take a CV signal and come into the sample and hold input. And what that does is it overrides the incoming audio as the signal to be sampled. So let me just grab a patch cable and grab an output from the cutoff CLFO here. push a really slow LFO in. Or I could use an envelope. Lots of fun. You've got a switch here for wet and dry. If I put the switch down, you've got only the wet output, so that really gives you the sound of this reverb circuit. And then you've also got a sample and hold output. So if you wanted to take the sample and hold from the incoming audio at the clock speed, you could then wire it around the rest of your system. So that's a basic walk through the module. Let's listen to a couple of patches. Let's have a look at a couple of quick patches. So I've got a basic subtractive synth setup here. A saw wave oscillator. Just coming out of the oscillator just off screen into the envelope and straight into Gats. Now importantly, I also have the clock output from the sequencer going into the clock input of Gats, which gives us, when I turn the CV up, it's going to give us some pleasing modulation that's in time with the sequence. Let's have a play. Where Gats is acting more as a static effect. Here I've got a glitchy loop coming from the gloop out of Gats into drab. Let's play around and have a listen. And just look for sweet spots with the offset and the CV. patch, Gats is doing something even more subtle. I'm not going to use the clock CV here. I'm not going to use the resonance. This is just the reverb and wasp-style bandpass filter straight into Cladastrad's granular algorithm. The effect is subtle, but it's so nice.